This series of videos are meant to demonstrate the functionality of the Logic Error Hunter. This particular episode is an introduction to the tool, and it discusses briefly its functionality, but all the rest of the episodes on this web page are showing more or less details about each individual function in the tool and how it's gonna be used. In general, the Logic Error Hunter tool is a software capable of verifying and testing the logic of PLC programs from a particular PLC brand. Its main functionality is concentrated under the File menu, as shown. The File menu contains menu commands which are executed one after the other for the typical PLC program testing procedure, and usually we start with the auto-generate tests for a program command, which allows the user to select the PLC program from the disk and open it, and once the program is opened, it allows also to select individual modules in the PLC program for testing. Once the user has done all this, the auto-generation procedure is started and tests for the individual modules in the PLC program are generated. It can be quite a few tests for each individual module. The tests are saved on disk, and also there is a test suite generated, which is nothing more than all the auto-generated tests listed in a file, which can later on be executed to allow the user to execute all tests for the PLC program in one step, as will be shown later. Finally, a report of the auto-generated tests is being generated and presented to the user on the display and as well on the disk, and which shows nothing more than each individual test being generated and specific information for each of the individual tests, like what's being tested and so on. After the auto-generation of tests, the next step in verifying the PLC program would be to run all the tests for it. And this is being done by selecting the command run existing test suite, which allows the user to open the auto-generated test suite containing all the tests being auto-generated and executing them one by one. While the tests are being executed on the PLC program, the Logic Error Hunter also logs test results in real time in the form of pass or fail for each individual test, and the logging is being done on the display as well as in a file. An alternative way of testing the PLC program would be to execute the code coverage for test suite command in the Logic Error Hunter, which effectively allows the user to execute the test suite as in the step described before, but with gathering code coverage statistics in the same time, which allow the user to assess how effective the PLC program has been tested by the auto-generated tests. Pretty much this command allows again to open a test suite and execute it, and while it's executed, the Logic Error Hunter gathers information about which parts of the PLC program have been exercised by the tests, and pretty much at the end, when the test suite execution is finished, a report is being generated for code coverage, which shows the list of PLC routines or modules in the PLC program and the percentage of code for each of one of them being covered by the tests executed on the PLC program. The aim, of course, is to cover 100% of all PLC code. So if some of the modules or PLC routines in the program are not covered, the user has to add some more tests by hand eventually, or re-auto-generate all tests in order to cover 100% of the PLC program. So we make sure that all of the PLC program has been tested by the test suite being auto-generated or manually modified. The final step in verifying a PLC program is assessing the results from the testing and rectifying errors in the PLC logic. And this can be done with the top menu command in the file menu, open PLC program for testing, which allows the user to open a PLC program and then select tests for it and run the tests, individual tests from the auto-generated tests, and run them on the PLC program by generating traces for PLC signals or PLC tags and analyzing the behavior of those signals. And the trace run can be executed and signals can be selected for trending. After the trace is executed, the signals can be shown in a waveform viewer, and the timing diagram of PLC signals can be created and analyzed, and the root cause of a problem can be tracked down and the PLC program can be fixed. Another way of analyzing problems would be again running a PLC test on a PLC program with putting breakpoints in interesting points of the execution of the PLC program and stopping the trace execution on a breakpoint or break condition, and from there on just running in step or cycle step mode or animation mode and watching particular interesting PLC signals or PLC tags and their values and how they change with stepping the code or cycle stepping the code, so that again a problem can be debugged and tracked down and the PLC program fixed. After all the tests that have been failing in the test suite execution have been analyzed and program errors being fixed, we rerun the test suite with the run existing test suite command and make sure that all tests in there pass. After that's being done, the PLC program pretty much is being tested and the verification process is finished, and the PLC program can be delivered for the next stage of the project or delivered for commissioning.